Before the video begins, I'd like to thank my viewers for giving me feedback on my videos and how to improve. It really means a lot. With that out of the way, on to the video. In my last video, I finished the CAD for Biohazard, my 1-pound plastic antweight combat robot. In this video, I'll be documenting minor changes and beginning the process of printing and assembling a testbed robot before the final robot assembly. For the uninitiated, the 1-pound plastic antweight combat robot class states that your robot cannot weigh over 1 pound, or around 454 grams, and must be made mostly out of specific plastics, with the exception of motors, fasteners, etc. Because of its materials and weight limitations, it is an excellent entry point into the sport, which is why I'm competing in it. My robot is a 2-wheel drive drum spinner designed to dish out big hits, while all being made out of super cheap materials. Its focal point is, of course, this gigantic drum that spans the width of the robot. Additionally, its 2-wheel drive system allows me to simplify my robot's design and focus more mass on the weapon. For those who viewed the last video, you may notice that the robot looks a little different, and it has a different name. Although I would rather stick to my original robot, I have good reason to change it. When browsing the filament before printing the test pieces, I realized that the minty green filament I had loved in my original design was only available in regular PLA Plus from Sunlift. Compared to PLA Plus 2.0, the regular PLA Plus exhibits worse cracking and impact resistance, both of which are critical, as I was using the mint green for my drum. Additionally, it came to my attention that there already existed a relatively famous 250-pound Battlebot named Biohazard. While I'd love to uphold its legacy, Big Chips number 19, it felt kind of wrong to use the name of such an important robot, and since I needed to change the colors anyway, I embarked on a renaming campaign. I liked the stark contrast of this cyan filament with the black body. When added to the robot, it brought to mind Cherenkov radiation, as made most famous by the radioactive blue flash from the Demon Core. I thought it sounded pretty cool as an inspiration, so I replaced the biohazard symbol with a radiation warning and rechristened the robot as Cherenkov. The name sounds a bit like Cherenkov, a famous shell spinner from the NHRL. Most importantly though, it sounds vaguely scary without being garish or in your face, as I've never been a fan of super death robot names. With that out of the way, I began printing. This will be a pretty detailed dive into my printing process, so if you'd like to skip to the finished version, the timestamp is here. I started printing parts out of spare white PLA Plus 2.0 I had left over from my previous projects. The wheel guards went first, and those printed fine, as did the uprights. However, it took quite a bit of time to print the drum, and not just because it was printed at 100% infill. I first attempted to print the drum without a brim at 100% speed, which, for a tall and skinny object, went about as well as one would expect. The drum got about 60% of the way up before falling over and spaghettiing. I tried printing it with a 10mm brim, and it got knocked over again, although not before depositing a bunch of filament off of the drum and up inside the hot end. I decided to pull out the big guns, and printed it at 50% speed with a 20mm brim, which upped the time to 7 hours. I printed it from 3:30 to 10:30 after I got home from school, and embarked on a brief side quest to finish my junior level 1 certification rocket. However, while I was printing, I was discussing the design of my robot with the NHRL Discord. One of the members mentioned that my counterweights were effectively useless, as they could just as easily bend a tooth themselves. That way, the tooth area is effectively 100% of the drum's width, making the weapon even better than before. In retrospect, this was such a silly oversight, so what else to do but print another one. I set the print to run overnight, as the 20mm brim and decreased speed had worked extremely well. By morning, I had the updated drum on my desk. Again, huge shout out to the NHRL Discord. They've been instrumental in guiding me through this process and helping make Cherenkov a killer little robot. I printed the body while I took another brief side quest to play drums at a gig and an open mic. When I got back, after 4 hours of sleep, I had all my 3D printed pieces ready to assemble the robot. The robot was temporarily assembled using hex socket screws as opposed to the button heads I had ordered. However, I lacked the specialized pieces for the robot: the M5 screw, M5 nylock nut, and the bearing. Additionally, the wheels I own are the wrong size. They were bought for a design with a larger wheel size, one I had built prior. Because of this, I wasn't able to complete a functional test robot until the components arrived, but more importantly, I was still blind as to the robot's actual mass. In my Google spreadsheet, I list the projected mass of each component and its respective quantities to estimate the total mass of the robot. However, I also make sure to include a measured column to note its actual mass. This ensures I constantly keep the robot inside the weight limit as I build. To streamline the process, I measured the entirety of the robot as it stands on my scale and marked the weight down. This eliminates sources of error in the projected mass calculations, such as wiring mass or improper rounding in digital mass statistics. The scale read 424 grams. However, the wheels are the wrong size and the bearing and fasteners missing. It required some screwery to get to the robot's actual mass. In my Google spreadsheet, a negative value will account for the difference in the mass of the wheels. Amazon lists the mass of the bearing on the product page. Onshape provides an estimated mass for the screw through the standard content import. However, I needed to import a McMaster-Carr CAD file for the lock nut so it doesn't have a mass I can use, because, for some reason, McMaster-Carr doesn't list the mass of the product on its page. However, DIN 985 specifications for M5 lock nuts list a mass of 1.4 kilograms per 1,000 lock nuts. So simple metric mass gives us a mass of 1.4 grams per lock nut. Another reason why metric is better, I suppose. By summing the values, we get a mass of around 442 grams, or about 97% of the weight limit. For now, that seems to be a reasonable amount of wiggle room. So what can I learn from a bare, unusable chassis which also has the wrong fasteners? Firstly, I can see that my solution of pulling the motor wires away from the drum still isn't enough. I fixed that in CAD by tweaking the geometry of the slot a little bit where the motor wires enter the trough. Additionally, I can verify tolerances. Although most of the tolerances were fine, one bit to fix is the captive nuts standing vertically, which were too tight. I increased the tolerances by 0.05 millimeters, which, believe it or not, is enough to make the nuts sit fine within their slots. Beyond that, I can measure the robot's mass as I mentioned before, and also get a sense of how the robot is assembled and what it looks like in the physical world, which is always gratifying. This is part of what I love about iterative design and the engineering process. There's always something you can learn. So what are my next steps? All of my parts should arrive within the next week, so the next upload will be, with enough luck, the process of printing and assembling the final robot. If you're interested in that, consider subscribing because I promise the next video will be much more interesting. Depending on how quickly I can finish the robot, you might get to see a little bit of destruction before I compete. Who knows? At any rate, thank you for watching. I hope you enjoyed the video. Have a nice day.